Hello friends. So please come live for an interesting topic of AVR. Aditya, you can also join. Okay. So this is briefing I will do again for this AVR circuit. We have a 440 line voltage coming to the transformer, which is a step down transformer. The supply from the transformer is step down and it will go to the bridge rectifier, which functions to convert the AC signal to the DC signal, means fluctuating sinusoidal wave to the unidirectional DC. And this is a capacitor circuit, and now it will go to the comparator circuit. It is a we can put four resistors or four diode also. It is acting as a bridge rectifier. So, what is the function of the bridge rectifier? Any disturbance or any interference, the circuit will get disturbed, and the feedback is part of the disturbance. So, this circuit has a comparator for the AVR. Any disturbance, either it is less uh, is more, it will reflect, it will give feedback to the amplifier circuit. I will explain the full function of this diode resistance why it is there in this computer unit. So what is this amplifier circuit? Amplifier circuit main function is because this signal is weak and very small. So amplifier function is to amplify the signal and send it to the SCR control unit. Now SCR control unit have some signal. So that signal is analyzed by the control unit and accordingly the gate is triggered. So here we have again a bridge rectifier type 4 uh, diode, two SCR and two normal diodes are there. So now this SCR control unit gives signal to the control give signal to the gate of the SCR. In SCR, what is the function? If we give more signal, the gate will open less. Means more to it is inversely proportional. If we give less signal, it will act more. So accordingly, it will generate the signal which will go to the DC exciter point, which is responsible to excite the main generator. This is a function of the AVR. If the AVR is sensing less voltage, so it will trigger pass all the signal and trigger the SCR so that the DC exciter will give more signal, more current to the and this will activate the give more magnetized field to the exciter circuit. So one question arises that this AVR is working continuously or it is working. So at the starting until this, it is achieved, rated voltage is achieved, it is getting triggered till the rated voltage is not achieved. Once the rated voltage is achieved, this rectifier is stable and no no disturbance is there means the rectifier is stable, so nothing is passing to the amplifier and nothing is there to trigger the circuit. So this will only give signal for the excitation to maintain that voltage. Now here is main component of the PR voltage sensing unit. It consists of before only I told you that voltage sensing unit consists of transformer, bridge rectifier, and capacitor. Mm, The function is of transfer is to step down the voltage from 440 to 110. Bridge rectifier to convert AC to DC and motor to DC. Comparator circuit have two fixed value of resistance, two general. A generator have its own resistance, but its resistance dependent on supply voltage. So principle of the generator it will achieve a breakdown voltage. So uh, avalanche breakdown we are saying we'll say that it is getting avalanche now. If we give less voltage, then semiconductor offer a high resistance. In the case of the general diode, and if we keep on increasing the voltage, its resistance will decreases, and at a time will come when the breakdown happen. It is resistance will be negligible. At the avalanche breakdown happen, instead of giving the voltage, the resistance is negligible. Now register have a fixed resistance value and a general resistance will depend on the supply of the voltage. The comparator circuit work on the Wheatstone bridge. Before only at it work on the Wheatstone bridge. As we know, in Wheatstone bridge, we have fixed galvanometer at the same place we put amplifier. When the bridge is balanced, no current will flow to the amplifier. Depending upon the amount of unbalanced or interference bridge, the error signal will generated and current flow through the amplifier. The error signal goes to the SCR and the S trigger the bridge rectifier. And this bridge rectifier is applied to the exciter field, which by the armature of the which is cleared by the armature of the alternator. Are we clear? So in the diagram, I show that this bridge rectifier will be error signal to the amplifier, and amplifier function is to push the signal and send it to the SCR control unit, and this will give signal to get the SCR only. So we are giving the SCR. So why we are using two SCR and two diode? Why not for all? I will explain in later. So this first you understand that this will give signal to the SCR. So gate voltage is controlled by the CR unit, and which is controlled further by the amplifier, which is controlled by the this disturbance imbalance error signal set by the interrupter. And from this SCR bridge, DC exciter coil is getting excited and create an activity which is cut by the armature of the alternator. We are clear after that. The error signal developed output comparator circuit will have a sufficient we want amplified. Okay. Now, why two SCR, why all four diode? So answer is depending upon the demand, we will regulate our output voltage and DC etc. coil. If we choose all four diode, then we will get fixed voltage. Understand? If we use all four diode, we'll get only fixed voltage. If SCR by controlling the firing angle to the gate, which is controlled by the SCR control unit, by controlling the firing angle, we can alert the output voltage. Even if we use force with SCR, then this is also okay. Because my main motive is to control the DC coil excitation. By controlling the DC excitation only, we are increasing and reducing the voltage emitted by the generator alternator. So firing angle is inversely proportional to the voltage. If we increase the firing angle, voltage is reduced. If we decrease the firing angle, voltage is increased. Very clear. My voice is clear. Okay, this come under the regulation chapter 11 of 1. Chapter 11 is enhanced maritime safety and security. The requirement of AVR. So 15% of the voltage fluctuation should be brought back into the range of 2.5 plus minus 2.5% within 2 seconds, but electronic AVR does the same work within 1.5 seconds. Excitation transformer does the same work within zero point 0.1 to zero point 0.2 seconds. So I told you before that this area is good for the voltage fluctuation of 15% plus minus of the rated voltage. Suppose 440, I'll calculate for you. Suppose 440, 440 is the percent voltage. So 15% into 15 divided by 100, 66 volt. So around 60 to 66 voltage plus minus it will brought back to the 5 to 10 voltage. It is 2.5%. Now question arises that excitation transformation is faster than electronic AVR. Then why we are not using? देखो तो दाल जल रहा है क्या दीदी दीदी वही है दीदी को बोलो तो दाल का स्मेल आ रहा है लेके जाओ बाबू को देखा दाल को पूछा था दीदी को because in excitation transformer we are using slip ring and process so maintenance is increases and also excitation transformer cover big space. Now here is the reason. We know excitation transformer response time is very less, zero point 0.1 to zero point 0.2 second, but it uses the slip ring and process, so maintenance is high and also excitation transformer covers a big space. Voltage versus time graph of AVR regulation. So you can see before the fluctuation is from minus 15% to the plus 15%. So AVR comes into action and this fluctuation will come down to the plus minus 2.5 of the rated voltage. So this is the time of action of the AVR from here to here. So for electronic transformer AVR, it is taking 1.5 second. For excitation transformer, it is taking zero point 0.1 to zero point 0.2 second. This is different. And as per the regulation, it should be less than 2 seconds as per the SOLAS. So both are fulfilling the requirement. And what is the location of the AVR? Location of AVR is either on the alternator only or it should be placed in the MSP, main switch board. And how many potentiometers? This question also been asked by the survey that how many potentiometers are there in AVR. If you don't know the AVR, you are unable to answer this question that how many potentiometer is there. There are three potentiometer. One is a main excitation trimmer, which is locked, secured by the pin. Second is the fine adjustment trimmer. We are using this trimmer to adjust the voltage. And one is AVR droop trimmer. This is AVR droop trimmer. We are generally not touching it. It is set by the manufacturer. Remote will be on MSB if AVR is limited. Under voltage or over voltage can be adjusted. So any one of you faced this problem of heavy under voltage or problem with the synchronizing, here is the answer. We can adjust this potentiometer. Hmm. Now, next topic is paralleling of the alternators. In ship, we have generally three, four, more than three generators. So, as per the ship's load, we are using the generator. If load is more, we have to run two or three generators in parallel to compensate that load. So, here comes the reason why we need to parallel a generator. एक से काम नहीं चलेगा, चार चाहिए, इन चार को एक साथ जोड़ना पड़ेगा. So main condition for tailoring. The main condition, the first one is voltage. The voltage of the incoming DG should be same as the voltage of the bus bar. Voltage should match first. We can check this voltage from voltmeter available at the panel. Frequency of the incoming generator should be same as the frequency of the bus bar. We can check this frequency in the frequency meter. Now, phase sequence of the incoming digit should be same as the phase sequence of the bus bar. This one is important, phase sequence. How we are going to check this phase sequence? So we can use synchronoscope, generally now available in all generator, to check the phase sequence of the incoming digit. We have few other method also, dark lamp method by meter also we can use that. So we can discuss this. The fourth one is phase angle of incoming DG should be same as the response. What is this phase angle? So there. First we'll see the phase sequence of the incoming wave. Suppose I have R by B phase. incoming DG first sequence is R, then the bus bar also the first sequence should be R. This is called phase sequence. You can see this graph. This is voltage by phase angle graph. In this figure, in this graph, we can make out that the incoming and the bus bar have a difference. So this difference maybe 10, 20, 15 degree difference in phase angle. So this is not visible to the delay bit incoming and difference is cause the voltage difference. If voltage difference is the capacitive range of the AVR, then AVR will compensate. If this voltage difference is within the range of the AVR, then it compensate. Otherwise, if not within the range, the power reversal happens and it will treat the generator. So what is phase angle of influence of shape as possible? When the when the phase R is at the peak of that time the phase of the R of incoming generator should also on the peak. Then phase angle is so normally if we are starting generator in the auto mode, if we press auto, the breaker will close at 12 o'clock, which symbolizes the phase angle same. Phase is same. How you will know in a synchronous? If the incoming generator voltage is speed is more, so the synchronous scope pointer rotate in the clockwise direction. The speed of the incoming generator is less, so the pointer will rotate in anti-clockwise direction. This means um, the incoming generator should be more than the bus bar running generator. That's why we require a clockwise direction of the pointer, slow and clockwise direction of the pointer. So in auto mode, it will go, that will go to o'clock. And if we are running generator in manually, so approach to 12, 11 o'clock, we are closing the breaker. Phase angle means line to line voltage should reach at peak. Line to line voltage should reach at peak at the same time. Now this is a synchronous scope. Function is very simple. RYB, we have two connection coming from incoming DG, which will go to the poles of the synchronous scope, and two two lines from the field of the bus bar. One will directly go to the armature of the synchronous code, which is the rotating part, and pointer fixed on the armature. And one line is going to the armature via resistance, and one with the impedance, reactance, inductance. Sorry. The current passing from the resistance will have voltage and current equal. and the current passing from the ductiles current will lag by 90 degree voltage. So here, first switch off the power to synchronous of one phase from the first by directly connecting to the alternator, armature, and other phase which is coming there is resistance where V and I are same phase, and there is a inductance also where I lags voltage by 90 degree. So armature dual current at different time. So due to dual current, rotating magnetic field will created, and by this pointer will try to turn, but rotation of the pointer will depend on the if the high, the pointer will turn clockwise, and if the distance is less, pointer will turn anti-clockwise. Due to this, torque will generated. Pole strength higher means that the incoming DG speed is higher. Pole strength lower means incoming DG speed is less. At the time of balancing, we have to keep the pointer in the clockwise direction. In auto, breaker will close at 12 in manual, close after 2 what it is when to close the breaker, incoming DG is fast or slow. And we need to switch off the synchronous after balance. When the breaker is closed, the field strength of the armature and the incoming DC will be same. So incoming in the bus bar at the same potential. If synchronous stop still switch on, then the fuel still there. Due to this, uh, torque will be there, and this torque is not utilizing, and this torque will be lost in the form of the heat. And due to heat loss, the temperature will increase, and we will not be able to replace. So these are the some topic for the MIT exam of 2005. I'll come with the next video. So also discussing about the relating to collection opinions, vocabulary of MIT question asked in the KOLKATA MIT. These are the basic questions they are asked. Okay.